What up, Algebra Squad? Here we go. This is the worksheet, the new lesson 3.2. The title of this sucker is Rate of Change and Slope. Notice in your worksheet that I put in between parentheses the word steepness. That is pretty much what slope is, or rate of change. I want you to think about it as how steep something is. More specifically, a line. So think about when you're walking, and let's say you're walking this specific trail. This is you, hello, and then you're walking this trail, right? Hopefully you understand that whenever you're walking through a flat line, it's very simple. Not a lot of energy is taken from you, just the normal amount, right? But then once you start to get into an area that is going upwards, that is when you have to exert a little bit more energy, right? So the red is going to be showing with a little bit more difficulty. Then once again, you continue through a straight path, which that's neutral, same amount of energy as you would in the first section. And then going downwards, we can all agree that that is where we exert the least amount of energy. We're actually trying to slow down, making sure we don't go, whoa, way too fast, right? So think about slope that exact same way. We are trying to figure out how much steepness a line has, or the steepness of a line. If a graph is curved, for example, like this, can we find the slope or the rate of change of a line that is sloped like that? Well, yes, but we need to do it with 2 points. We can only find rate of change or slope with straight lines. That means if we can find 2 points on this curved line, yes, we can find the average rate of change. But what happens is we are actually trying to find when we find slope, it's actually with a straight line. So we are able to find the slope of this green line right here, which will give us a good estimation. And once again, if we want to find the slope of these two dots, or how these two or how the graph is changing from one dot to the other, we would have to make a straight line and find the slope of this line, right? So slope or rate of change is used with straight lines. Can we find the slope of a curved line? Yes, we can, but it's kind of like an estimation, like I just said. Okay, so just like the lines that you see here, some hills, I want you to think about this red hill right here and this one right here going upwards. Some are harder to climb than others, okay? So that means that the steepness is going to be a lot higher on this one right here than it is on this one. So our job today is to find the actual numbers, the actual slope of a line. So there's going to be a number. Let's say that this has a slope of 2. If that has a slope of 2, I'm just making that number up. Then this other red line needs to have a slope of, like, I don't know, say 7, which is a number greater than 2. Now, if we compare this green one with this green one, which one has a greater steepness? Meaning, which one is going to make you kind of like tumble down that line a lot faster? Hopefully you're thinking this one. Okay, it is pointed downwards a lot more. So if I call this, I don't know, 6, then this has to be maybe a 3 or a 2. Okay, so same way. Now, you need to understand also something, that whenever a line is, whenever we're walking downwards, it's going to be led by negative numbers, okay? So if we're going downwards, if it is a downward sloping line, it will be with negative numbers. Now, how do I know when it's going downwards? Because we're walking from left to right. Just like reading a book. Whenever you're reading a book, you read it from left to right. Anywhere that you're going downwards from left to right, that is a negative slope. So let's go ahead and jump right to it. See this first one right here in our worksheet. How can we determine the slope of this line right here? The first thing I want to look at this line and understand is that if I walk this line, it's going to be going upwards. That means, really quick, I'm just going to put here on the top of my worksheet a plus. That means it's an upwards walk. It is a positive slope. It sucks. We need to exert a lot more energy, but it's an upward walk that we need to take up this line. Okay, how do we find the slope of this line? If we're given a graph just like this, the best thing to do right now is find 2 points. After we find 2 points, say this point right here, and remember, you want to find points that are on intersecting vertical and horizontal lines. What am I talking about? Well, if you could see right here and right here, that point is intersecting at -1, perfectly at -1, and the -3. Okay, so that is a perfect intersection. Don't find one that is on decimals. Okay, so don't find one that it's like right here, because that's I don't really know what that number is right here, and I don't really know what that number is right here. We would have to take a guess. So find a point in perfect intercepting lines. So, and I think there's another one right here. So let's go with that one. Now, it's super simple finding the slope of a line when looking at a graph, because we're actually looking for something that's called rise, meaning how much do you go up and down. I know it says rise, and rise we usually typically talk about up, but we're talking about the up and down movement. And run, R-U-N, is going to be vertical movement, left and right. Okay, rise over run. So slope is rise over run. How much is the vertical movement and how much is the horizontal movement to get from one point to the other? So let's look at the rise. How much do I need to get from this point to this point vertically going up? Hopefully you understand that it's 1, 2, and that's it, right? Just 2 jumps up. So my rise is up. Now I went up 2, so it's a +2. Next, how much do I need to go left or right? Hopefully you understand that I need to go to the right. From here, I'm going to need to go to the right 1, 2, 3, 4. So it's 2 and 4. 2 up and 4 to the right. Whenever we go up, that's positive. Whenever we go to the right, that's positive. If we go down, it would be negative, because look at your numbers when you go down, your Y numbers. And when we go left, it would be negative with those numbers, because look at your X numbers. Your X numbers are negative. So this is 2 over 4, which we know that to be 1/2. Okay. All right. Let's look at the next one. All right, we have a slope right here of this line. We're going to do the same exact thing. Really quick, sorry, before we go to the next one, I want to show you what 1/2 means, or 1 over 2. 1 over 2 means that this line right here, let me just do this so we can hide the second one. 1/2 means that this line that's right here is created by a staircase that has a blueprint of 1 over 2. What does that mean? That if I go 1 and to the right 2 forever, I will always land on this line. For example, check it out. Let's say I'm right here. If I go up 1 and to the right 2, I'm on the line. If I go up 1 to the right 2, I'm on the line. If I go up 1 to the right 2, this is the blueprint, or the rate of change. This is the pattern that creates this line. This is what creates this line. A line is created, or a sloped line is created by its pattern of rise over run. And in this case is a 1 over 2, okay? Some students are gonna go, whoa, Mr. C, hold on. What if I chose this point right here and this point right here? What if I choose the wrong points? There is no choosing the wrong points. Now, remember, you need to choose the points that are on perfect intersections, and then you won't have an issue. What happens if you choose those 2 points, or points that are different from the ones that I chose? Let's see what happens. 1, 2, 3, 4. That's a rise of 4. And then my run would be 1, 2, 3, 4, 5, 6, 7, 8. 8. It's a 4 over 8, a rise over run, 4 over 8. 4 over 8, once again, is reduced by, when you divide them both by 4, it turns into 1/2. So you cannot do this a wrong way, okay? There's no way of choosing the wrong points. Let's look at the second one over here. I want to encourage you to pause this video right now for about 30 seconds, find 2 points, find the rise over run, and that's it. All right, so I'm gonna go ahead and choose this point over here and this point's over here. Hopefully my points are different than the ones that you chose, so we could see that it's okay for them to be different. Slope is rise over run. I'm going to keep writing this so it's ingrained in my brain, rise over run. And I want to see how much I need to go up or down and to the right or to the left. Now, Mr. C, you went from this point to that point. That's how you went. Is it okay if we go the other way, like from the other point, from the top one to the bottom one? It's okay. Just be careful with your symbol. What I'm trying to say is, when we are standing here all the way to the left of this line, you need to understand that we're going to go walking up this line. We go up this line. That means that your slope at the end of it needs to end up being positive. So what I'm trying to say is I'm going to do this backwards. I'm going to actually go from this point to that one. Okay. So from this point right here, and actually I'll do it downward so you know that it's okay. What is the vertical movement that I need to take? 1, 2, 3, 4, 5, 6. I need to go down 6. That means down 6 is negative. So I need to put -6, right? Because look at my numbers. To show that you're going down in your y's, you need to subtract. Okay, so, and now how much do I need to go to the left? I need to go 1, 2, 3, 4, 5, 6. Ooh, I need to go 6 again to the left. 6 to the left. That makes me need, or I'm sorry, that needs to be subtracting. Okay. Any number divided by itself is going to be equal to 1. Positive 1, because it's a negative divided by a negative. It's a positive. Okay. Now, say you did it a different way. It's okay. It doesn't matter. Say you chose this point right here and this point right here. Doesn't matter which point you choose, because look, 1, 2, 3, that's 3 going up. And then 1, 2, 3, that's 3 going to the right. 3 up, 3 going to the right. 3 divided by 3 is 1. Same thing. Same thing. There's several different ways that you can ask me how to do this. If you're getting a slope of 1, you are getting it correct. If you're getting a slope that's a different number, you need to pause the video right now and raise your hand. Let me come to you and help you out. Now, just to finalize this idea, I want to show you once again how this line is made up by this slope. And I always want to look at slope like a fraction. Even though the slope is 1, I'm going to make it 1 over 1 so I can teach you something right now. This line is made up of 1 over 1 because this line is made up of going up and to the right 1, going up 1 to the right 1, going up 1 to the right 1, going up 1 to the right 1, up, right, up, right, up, right, all by ones. See, if you follow up 1, right 1, this will make this line. You will find a point on this line. That is why this is called the rate of change of this line. This line is changing at that rate. It's going up and to the right at this rate right here, 1 and 1. All right. Once again, remember that your slope is positive. This line is going upwards from left to right. We're going upwards from left to right. All right. Positive numbers. Third one, encourage you to pause this right now and do it on your own. All right. I'm going to go ahead and grab 2 points from here. I'm going to grab this one here, and I'm going to grab this one here. You can go ahead and figure it out whichever way you want. You can say to yourself, I need to go to the left 3 here. I need to go to the left 3 here. And then I need to go down 3 and 3 is 6. So I need to go down 6, right, to get there. You can do it that way, right? You got to go left 3, down 6 to get to that point, right? You can make that fraction. Or you can say that you need to go to the right 3 right here, to the right 3, and then up 6. Again, up 6, right 3. So it's a positive 3, a positive 6. It is going to be the same. Mr. C, how is that the same? How is a negative 6 over negative 3 the same thing as 6 over 3? Remember that a negative and a negative, right? Remember that a negative divided by a negative cancel out. So essentially, these negatives aren't really there in your final answer. A negative 6 divided by a negative 3 is a positive 2. Just like a 6 divided by 3 is still a positive 2. So I'm going to go ahead and leave it like that. My rise, the amount of jumps that I'm going up, is 6. And right now I'm taking this method that I have written down on the board. So in case you're going, wait, I thought it was negative 6. I'm just taking this method that I left. So my rise, my vertical movement is positive 6. So I need to, from the bottom one to get to the top one, I need to move up 6 units. And then from the bottom one to get to the top one, I need to move to the right 3. So it's a positive 3. And we did say that 6 divided by 3 is 2. Once again, even though this is my slope, we always want to look at slope like a fraction. So how can I turn a number into a fraction? Just put a 1 under it. Once you put a 1 under it, you can now, you can now understand that this line is made up of the rate of change of this line, or the rate at which this we get from one point to the other, is up to the right one. If you follow this pattern, you will land on a point. For example, starting at this point right here, if I go up to 1, 2, and then I go, did I? 2, 3, 6. Did I choose a perfect line here? Or perfect points? What points did I choose before? Did I choose this one and this one? So 1, 2, 3, 4, 5, 6, and then 1, 2. Ooh, oh, mistake. I made a mistake. I wrote this wrong. I wrote this wrong. Whoa, 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 whoa. Oops. Well, I hope you guys were watching this video, and I know some of you already walked up to me saying, Mr. C, you made a mistake. Whoops, sorry. It's supposed to be 2 jumps. Again, 1, 2, 3, 4, 5, 6 to the right, 1, 2. Yeah, that's it. It's 6/2, which is, whoa, it's a, and that shows you that you can, even after you do the work, you can check to make sure that you did it right. Again, it's a 3/1, right? Let's see if that's correct. From this point, if I go up 3, 1, 2, 3, and I go to the right one, do I land on the line? Yes, I do. Once again, 1, 2, 3 to the right one, I land on the line. There it is. Perfect. Mess up, it's okay. Mess up is okay. Just understand how your line is supposed to look. When you're all done, you go, is this true? Is this right? My slope is a positive number. Is my line going up from left to right? And it is. It's going up from left to right. I'm going to put a little reminder right here. Since all these 3 lines are going up from left to right, my slope should be a positive number. Now, the next thing I want to ask you is the following. If you were to climb, if you were a person, a little tiny person, and you had to go up these lines, I want you to put them in order. Which line would be more difficult to, from more difficult to least difficult? Which line would be the most difficult to climb? This right here would be the most difficult to climb. Why? Because it's, look at how much steep this line is. That's insane. That's probably maybe even impossible to climb. And the easiest one to climb would be this one, right? This one right here. That's a simple walk. This one right here, that's a good workout, right? But look at the numbers. The numbers don't lie to you. 1/2 is the smallest number out of these 3. The number 3 is the largest number out of these 3. Number 1 is in the middle. That's exactly how we just define these lines as well. This is the most steep line right here. That's the most steep line. This is the least steep line, making it the smaller number. Okay, keep that in mind. All right, now we're going to jump into some negative sloping lines right now. You could see the middle of your worksheet. These next set of graphs, they're all going downwards. Okay, so when you're reading it from left to right and your line is going downwards from left to right, you need to have a negative slope. It needs to be a negative slope. So after you answer it, look at your number. Was it positive or was it negative? Does it look correct? Or if you're looking at it from left to right and your line is going upwards like that, it's a positive number. Then we're going to talk about what happens when your road is flat. 0. Ooh, that sounds interesting. We're going to talk about it in a second. All right, so I want you to pause it right now. Choose 2 points right here and find the rise of a run. Do it. All right, here we go. I'm going to choose this point right here. I'm going to make sure not to make another freaking mistake. Even though, to be honest with you, the projector right now is making it very hard to see these little lines. So my rise over run right here. I'm going to put rise over run. My rate of change. How much does it take me to get from one point to the other? From this point, I need to go up. How much do I have to go up? Well, I can see that I need to, and I'll show you what my brain does so I can kind of explain to you how quick, maybe not. Right now, I'm at -2. To get from -2 to right here, that's 2, right? You have to go up 2. And then from, because you're at 0, this right here is 0. To get from 0 to this height of 3, you need 3. So that's a total of 3 jumps. So 2 jumps here, 3 jumps here. That's, did I just say that's a total of 3 jumps? Total of 5 jumps. My brain is saying a lot of things. All right. So, I want to keep 5. Okay, so I need to go up 5. And to the left, I need to go. Notice that I'm at the number 4, and I need to get to this number right here, which is 1. So I need to go 1, 2, 3. To the left, 3. Okay, 1, 2, 3. Okay, making sure that I got it right. So my rights, I need to go up 5. My run, I have to go to the left, 3. Okay, 5/3. Done. I cannot simplify this fraction, so I'm just going to leave it like that. Now, really quick tip. If you are having trouble understanding when do you put a negative, Mr. C, when do I put a negative? When do I put a negative? I have something that might help you. Okay, I have something that might help you. If you want to deal with the negatives in an easier way, you can. How do you do it? Well, before you even start, look at your line and say, oh, this is a downward sloping line. Oh, this is a downward sloping line, reading it from left to right. So right off the bat, do like we did before and put a negative, put like a big negative sign right on your graph. So you know that at the end of it, you can just put that negative sign on it. And if you're thinking, which number does it go on, Mr. C? What if I did 5/3, right? And I didn't really care about my negatives. I just put 5/3. Which number do I put it on? Remember that when you have a fraction and there is one negative, it doesn't matter where you put that negative. It doesn't matter if you put it on the 3, right in front of the fraction, or on the 5. It doesn't matter. It still means the same thing. Whoa, wait, what do you mean? Because you went left 3. You didn't go down 5. Yeah, but we can go down 5. What? What is he saying? Watch this. If we decide to put the negative on the 5 and the positive on the 3, or leave 3 positive, look what happens. From this point right here, wouldn't we have to go down 5? Look, down 5, and to the right 3. That is where we could get a -5 and a +3. It's the same thing. We're just going downwards now. So it's the same slope. Remember that fraction is division, and the division of a -5 divided by +3 is the same division as 5 divided by a -3. You're still going to get the same thing. What the calculator is doing is dividing these two numbers, and it's going to put a negative symbol. It's just going to grab your negative symbol and putting the fraction. What's 5 divided by 3? Boom, 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 boom. It's going to put it right there. Okay, so that's all it's doing. So I'm going to do the next one just like that. So I could see if we understand it. All right, so the next one, let me look for 2 points. I could see that there's a point right here and a point right here. Rise over run. Up 2. And then this way we go 1, 2, 3, 4, 5. 5. 2 over, okay, don't forget, one of the biggest mistakes you can make right now is write your fraction in a different way. A lot of people are going to write 5/2. Make a mistake. It's 2/5. It's your up or down movement, is your up or down movement over your side to side movement. It's vertical over horizontal movement. And then, okay, you're like, oh, whoa, okay, so what happens here? What do you do with your negative? Nothing. Don't stress it out. Just put your negative wherever you want. I'll go ahead and put it right now in the middle. And I'm done. -2/5. Done. Whoa, what? Really? Just like that? Yeah, just like that. This next one, let's go ahead and choose 2 points. I can encourage you to pause right now and do it on your own. Okay, I have that right there. Rice, I'll go ahead and ask myself 1, 2, 3, 4, 5. I always like to go up. I don't know why. That's just me, but I already taught you that you can do whichever way you want. As you can see right here, we went down, right? My brain always wants to go from the bottom point to the top point. I don't know why, but it doesn't matter. So 1, 2, 3, 4, 5. And then to the left 1. And then to the left 1. So this is a rise over run. And let's not forget, don't forget to put your negative. And we know that this simplifies to anything divided by 1 is just itself. So that right there is my slope. Slope right here, slope right here, and slope right here. Remember that slope, or your rate of change, is the pattern that your staircase has. Is the pattern that makes your staircase. So if I go again, 1, 2, 3, 4, 5, and to the left 1, I will land on the line again. Remember, slope or rate of change is what creates your staircase. Feel free to divide your numbers. I know that I will rarely tell you this. I always like to look at slope as a fraction. Always like to look at slope as a fraction. We normally hate fractions and we're scared of fractions, but when you think a bit about it, if you think about it as rise over run, just two different numbers, then it makes a lot more sense. So if you have, so if you could compare it to this, if I were to ask you, what does the line look like if it has a slope of -5? Your brain needs to go, oh, a slope of -5 means rise over run. You see, so you're gonna want to put that denominator. So it's always easier to think about it as a fraction right away. So I'm gonna do the same thing that I did before, which is I'm going to compare these numbers. 5 divided by 3 gives me a -1.66 repeated. 2 divided by 5, 2/5 is 0.4, -0.4. And then just -5 is just -5. And then you can compare these numbers to see which number is bigger, which number is smaller. And there you go. Look at the size of the number and look at how much your line is tilting. Okay. Put that information together. All right. What happens when our line is just straight across? Straight across lines are horizontal lines. Okay. They have a slope of 0. Why do horizontal lines have a slope of 0? Because just if you take the idea that I was talking to you guys about before, you're the person, right? And you're walking. Well, if you're walking on the road and the road is just flat, that means that there is no slope. There is no steepness. There's a steepness of 0. And the math behind it, if you want to do the math or understand the math behind it, it's still rise over run. Rise, meaning how much do we go up, is nothing, 0. Rise is 0. And run, in this case, run would be the length from here to here. Once again, from this point to this point is 5 units. If you grab your calculator and you do 0 divided by 5, you're going to get 0. Any number, 0 divided by any number will always give you 0. So very simple. Don't overthink it. If it's a horizontal line, it has a slope of 0. But what if it's a vertical line, which that is an impossible line to climb? You wouldn't be able to climb a line that looks like that. Well, if you grab your calculator and you do this math right here, see the point that goes from here to here. Rise over run. How much do we go from here to here? That is 3 units that we go up. Is there any movement from side to side? There is not. There's a 0. That's why we have that 0 here in red. Okay. So if you grab your calculator and you do any number at all divided by 0, it will always give you error, undefined. You cannot grab something and divide it by 0. Always go to the idea of, if you have a bag of candy, dividing means to give equally, right? Give equally. So you're giving equally, and then if you still have more candy, you go once again, you go around and you give everybody one. But if you have a bag of candy and you have nobody to give it to, how many do each person get? That's weird to say, right? If there's nobody to give them to, the question is, how many do each get? It's undefined. There's no answer to that. There's nobody there to give candy to. So that last one is a bit tricky because you cannot divide by 0. So a straight line going up and down, which is a vertical line, the slope is undefined. That is the word that we use, undefined, undefined, undefined. You're going to see me use a lot that, undefined. All right, super simple. All right, let's move on to something a little bit more interesting. It's as easy, but more interesting. What happened if we're not given a graph? Because we just did all these 6 graphs, we are able to tell rise over run, very simple. But what happens if we're not given a graph and we're just given the points of a line? And we need to tell the slope of a line with just the 2 points given to us. If you're thinking, oh, let's graph them, that would be okay if you have a lot of time. In a quiz, you're not going to have a lot of time to do this, to graph it. I mean, if you do, kudos to you. Yeah, great. But to save you a lot more time, there's actually a strategy for this. And what I'm about to show you right now, don't do it on your paper. I mean, do it or not. It's up to you. So let's go ahead and talk about what is this strategy. What is rise over run essentially? Okay, again, you don't have to take these notes right here. I'm just going to show you what is rise over run. Rise over run is us trying to find the slope of a line by asking ourselves, how far apart are our points vertically? And you can see it's from 2 to 5, which is 3. And then horizontally, it goes from 1 to 3, which is 2, right? So this has a slope of 3/2. Okay. How did we get those numbers? How can we get those numbers instead of, let me do this. If you don't have any of this, how do you get from this and this? How do you get that? Now, it's hopefully your brain is working right now. The 3, where did we get the 3 from? What impacts what to make 3? 3 is generated by our up and down movement. Up and down movement is your y movement, right? Your y numbers. Your y-axis is your up and down movement. So if you look at your y values for these points, let me go ahead and erase this. If you look at your y values for these points, which is this one right here and this one right here, how do you get 3 out of that? Well, the difference. And remember, I've said this before. Distance between two numbers is difference, right? The distance between 5 and 3 in a number line is 2. That's distance. That's why we get, wait, I just mixed up the numbers. Sorry. It's 5 and 2. The distance between 5 and 2 in a number line is 3, right? And the distance between 1 and 3, right? 3 minus 1, that distance is 2. So that's pretty much it. All we actually did is we grabbed our y values and subtracted them, and we grabbed our x values and subtracted them. Or that's essentially what we did without doing it. So there's a formula. This is how we can find the slope of a line with just the points given to us. Now, just go ahead and write it, because I know the first question that you have is, what in the world is this right here? These are called, now I forgot the name of this. I think it's a, oh my God, I had the name in my brain right now. I was going to say it, a subset or a, oh, okay. I'll tell you guys in person. Or it'll come to me. I'll tell you what these numbers are, but these are tiny little numbers, right? These are tiny little numbers to the bottom right. So it's like the opposite of an exponent. An exponent would be this. Right now, yeah, I think it's a subset. It goes like that. This has nothing to do with math, meaning you don't add or subtract or multiply. You don't do anything because of these numbers. What these are just a way to label something, right? Because we have 2 points. We have that point and that point. Instead of calling it, whenever I want to ask you about the x value of one of those points, it gets tricky, because it's like, which point are you asking us about, Mr. C? Are you asking us about the x value of this point right here or this point right here? And then I'd be like, the point that's on the red point. Which point? I know right now you're saying, well, just say the top point or the bottom point. Well, in math, when we're working with several points, we just call them point number 1 or point number 2. So, if we were to call this, and it's however we want to call it, if I were to call this right here, this point right here, point number 1, we would say that point right there is my x1, y1. Okay, that will make my my 3, my x1, or the x value for my first point, and then the number 5 is the y number for my first point. So that means that we will call this point my point number 2, where it has an x2, y2. That's how you say x2, y2, or x1, y1. You don't say it any other crazy way. That means that my 1, 2, the 1 is the x value from the second point, and the 2 is the y value from my second point. That's all there is to it. So let's go back to the actual question, and now you can start writing in your paper. What is the slope of a line that contains the points that and that? Well, let's go ahead and get started with that slope formula that we did. The slope formula, or the way that we find slope, by the way, this right here is the, I know it's so stupid. Why the letter M? M represents slope in math. I don't know why. Honestly, I haven't really cared about looking it up as to why. But M is the letter to represent slope in math. The formula would be y2 minus y1 divided by x2 minus x1. Now, I'm about to tell you a secret. The order of this, a lot of people might think, oh, Mr. C, do you have to write it this way? I'm going to say, to play it safe, yes. Yes. Always keep it in the order of the formula. Do not switch the order of the formula. Do not switch the order of the formula. Because remember that the formula is subtraction. So subtraction is not the same. 5 minus 2 is not the same thing as 2 minus 5. Can I actually teach you guys another way that it doesn't matter the order of the formula? Yes, but if I were you, I would stick with this formula. Just put this formula in your brain. Those of you that want to learn a little bit more, the other way that you can write it is keeping it consistent. If you want to write the y1 first and then the y2, okay, but you need to write the x1 first, subtracted by the y. Wait, that's supposed to be an x. By the x2. I had a brain fart right now. Okay, so if you do want to switch it up, then it's that way. So I'll explain to you why it matters, or how it is that we can remain consistent. The first thing that I'm going to do is I'm going to label them. I'm going to actually name my points. There are 2 points right here. We have this one and this one. Which one do I want to call point number 1? It don't matter. So let's just call this one point number 1. So that's my x1, my y1. And I'll call this point number 2. So you are going to be the x coordinate for point number 2. You're the y coordinate for point number 2. And now we put it in our formula. And that's it. There's nothing else to it. So let's do y2. Y2 is -1. And I'm going to subtract it by y1, which is -5. So therefore, I need to use parentheses so I can make sure I put in -5. Remember that this subtraction already comes from the actual formula. All right. X2 is 5 minus y. Wait. Did I just say x2? Whoa. Which it was right. What am I doing? Hold on. Okay, so x2 minus x1, which is 11. Sorry. I just have a lot of craziness in my brain right now. You should see someone. Why? I already have 40,000 people talking in my brain. I hear crazy people. Ah! All right, so let's do this math. A lot of people are going to trip out with the math that I'm about to do right now. A -1 plus minus minus a -5. Remember that minus negative is actually adding. So a -1 plus 5, a -1 plus 5 gives me 4. Whoa, if you don't believe me, put in your calculator. And then 5 minus 11 will give me -6. So that is going to give me 4. Wait, sorry. I'm thinking of dividing right now. If we can simplify this, I would divide it by 2. Simplified, divide by 2, top and bottom. So I can get 2 over -3. Okay, 2 over -3. And I'm done. That's done. Now, for those of you that are kind of curious as to, is it okay if we flip the formula, doing it the other way where we wrote the y1s first, and then so y1 minus y2, x1 minus x2, is it okay if we do it that way? I'm going to show you how the math will solve itself out to become the same thing. So once again, line up your 1s and line up your 2s. As long as you have your 1s and 2s lined up, you won't have a mistake. Notice that my 2s and 1s are lined up. As long as that's done, it's okay. It will yield the same answer. So y1 is -5 minus -1 divided by x1, which is 11, minus 5. You're going to see now that instead of me having the negative on the bottom, the negative is going to be at the top. So -5 minus a -1, that's the same thing as adding. -5 plus 1 gives me -4. Notice that the number's same, but the negative is now working itself at the top. 11 minus 5 is 6. Look at that. Remember from before, I told you that if you have a negative symbol on a fraction, it doesn't matter if the negative is on the bottom or on the top or on the side, as long as there's one negative, okay? So with that said, if we simplify this, we get -2 over 3, okay? I'm gonna go ahead and wipe this off so I can show you guys something really quick. Our slope was 2 over 3, and let's put the other one right next to it, -2 over 3. I'm gonna show you guys something really quick. I copied and pasted this from Desmos, and I'm gonna show you how this was accurate. So these are the 2 points. I graphed them. So there is a line that contains these 2 points. And the graph looks like that. Wow, that was pretty sweet and straight, but I'm gonna take that off. So I'm gonna see if my slope was accurate. If I go up 2 and to the left 3 or the vice versa, looking at my negatives, let's see if I can get to it. So rise of 2. So 1, 2, that lands me here. And then, so I went up 2. That means I have to go left 3 if I'm looking at that one. 1, 2, 3. Okay, that means that there's a point right here on that line. Again, I'm going to follow the same pattern. 1, 2, 1, 2, 3. Boom, there it is. Again, 2, 3, 2, 3 is the blueprint to create this line. Okay, that is why this has a slope. And look at the line. Does the line go up or down? Does the line go up or down? Does the line go up or down? Remember that you start your walk all the way. Oh my God, I drew a little weenie on the guy. They don't want to draw a weenie. So you start all the way at the left and you have to walk the line from left to right. That means that this line is going downwards. I need to have a negative slope. So did I have a negative slope? Do I see that I have a negative on my slopes? Yes and yes. You see, either of them is negative. And I can prove that this one is also correct because I can also go down 2. Look, that's down 2 to the right 3. Down 2 to the right 3. Again, down 2 to the right 3. Down 2 to the right 3. It's the same. You can create the little staircase above your line or under the line. The same idea applies. Okay, hopefully this is getting a little bit more easier to understand. It's the thing that makes it a little bit difficult is all the right things that you can do. There are so many right things that you can do. It'd be a lot easier if it was just one way to do it. If there was only one way, everybody can just agree, be like, okay, that's it. We're only going to do it that one way. But I'm showing you all the different ways that are okay to do it. All right, let's go ahead and get these suckers out of the way. So we have this word, or not really this word problem here, but we have a table of values where we can easily just make up a word problem about it, right? We have amount of flour and then pancakes. So right now we're going to use this table to find the rate of change, find the slope of this. Find the slope. So find the rate of change of the function by using 2 points from the table. Any 2 points. They didn't tell you which points, it's any 2 points. The first thing you got to understand is a few lessons ago, we learned how to tell if a table creates a line. A table creates a line if your X and your Y numbers have the same, or I'm sorry, have a pattern by addition. You could see that from 2 to 4 and from 4 to 6, there is a pattern of addition of 2. And if you see from 12 to 24, that's a jump of 12. From 24 to 36, that's also a jump of 12. So yes, this is linear. It is linear. It's not asking us. It's not asking us to determine if it's linear or not. It is already a linear function. I'm just reminding you of something that we've learned in the past in case you're like, whoa, how do we know that this is a line? Okay, this is a line. That means that these points all fall on the same line. They all have the same slope. Mr. Z, which 2 points do I choose? Which 2 points do I choose? It doesn't matter. They lie on the same line. This line has a slope. All these points will take you to that same slope. For that reason, we're about to find the slope of this line 3 different times. The first time we're going to find the slope of this line is by using the points. Let me see if you guys have enough room on your paper. Yeah, you do. So make sure you guys are working tight right here, okay? So the first one that we're going to use the 2, 12. That's my x's and my y right there. And 4, 24. All right. Now, we're going to go ahead and find the slope of from that point to that point, from the 212 to the 424. And let's go ahead and call the top one. That's going to be my 0.1. So that's going to be my x1, y1. And then the bottom is going to be my x2, y2. Okay. So I'm going to need my formula, y2 minus y1 over x2 minus x1. So y2 is located at 24 because we said 24 is going to be my my second point. Y4, 24 minus the y of my first point, which is 12, divided by x2, which is 4, minus the x1, which is 2. That's it. What does this turn out to be? 24 minus 12 is 12. And then 4 minus 2 is 2. 12 divided by 2 is 6. So we have a slope of 6, or 6 over 1. All right. Bada bing. Now we're going to find the slope. I'm going to show you again visually what just happened. There are 3, and I'm just making these points up. I'm just making them up. It might not even be a downward line. Actually, whoa, let me actually change that. You see that we got the slope of 6? 6 is a positive number. So I'm going to make my line go up. So I'm just going to give you like a quick sketch of maybe something that's happening. So right now we just found, we decided to grab these 2 points, which I'll just go ahead and say we found the rise of a run, right? So let's call it 6 and 1, rise of a run, right? 6 over 1, rise over run. And that's what happened. So I'm about to prove to you guys that from this point to this point is also 6 over 1. And you're like, oh my God, your sketch doesn't make sense. 6 is so much smaller than 1. I get it. It's just a sketch. All right, so let's go ahead and find 2 or look at 2 different points. Let's look at 424. That's going to be, I'm going to call that now my first point. So that's my x1, y1. And let's look at 6, 36. Okay, so I want to make sure, or I want to just do this so I understand that it does make the same slope. It's the same line, so it should have the same slope, right? So y2 minus y1, that's my slope formula, x2 minus x1. Okay, y2, so the y of my second point is 36 minus 24. And then my x2, the x for my second point is 6, subtracted by the x from my first point, from my x1, which is 4. What do I get here? 36 minus 24 is 12. 6 minus 4 is 2. Look at what we got. 12 divided by 2 again, which once again gives us 6. There it is. Now, the question didn't ask us to do it multiple times. We did it twice just to show that it is the same line, therefore it has the same slope. If you have points that are on the same line, it will generate the same slope. There's no reason why the same line will have a different steepness to it, right? Steepness is how much the line is tilting. All right, go ahead and pause this sucker right now and check your work. All right, here we go. So find the rate of change. Really quickly, if I ask myself the difference between here and here, I'm at 125. If I go from here to here, what's the difference from there to there? That's also 125. And then from there to there, from the 725 to 8.5, that is 125. So this right here stays the same. It's not asking us to find the pattern. I'm just reassuring myself I understand how to tell if the numbers on a table make a straight line. So I know that the difference here is 125. They're all the same. And then if I do the subtraction here on the other side, so what is 1992 minus 1577? I get 415. So the difference from here to here is 415. So if I have 415 and I add it to 1992, do I get 2407? Yes. Yes, I do. Plus, again, 415. And this is something that I can just do on my calculator. You don't have to write it on your paper. It's just so we just have that peace of mind. This is a line. It's a line. All right, so go ahead and choose 2 points. Label them your x1, y1, your x2, y2. And then from there, put in your slope formula. I'm going to leave you guys right there. Complete this one, and we'll pick it up from this one. Peace out.